Hello learners and welcome to Operations MIS ERP, Problem Solving and Reporting. We will be focusing on monitoring and efficiency. In our previous session, we focused on scheduling, material flow, and safe shutdowns. Today we cover operations management, MIS ERP systems, structured problem solving and reporting. Turn to someone next to you and say, what daily decision would be easier if you had clearer information? Let's begin. By the end of today, I will explain POLC in operations management, describe how MIS ERP supports production, apply a structured problem-solving cycle, identify cost drivers, and complete accurate shift reports. This prepares me for EISA and plant duties. Operations management means turning inputs into safe, high-quality outputs, planning resources and production, organizing people and materials, leading by coaching and ensuring standards, and controlling by measuring and correcting. I plan by reviewing schedules and materials. I organize operators and equipment. I lead by guiding behavior and reinforcing SOPs. I control by checking output versus plan and escalating deviations. Here is your first activity. Open your workbook. Write one sentence under planning, organizing, leading, and controlling, describing how you apply each. Share with a partner. Let's begin. MIS Management Information System. ERP Enterprise Resource Planning System. These systems integrate production, materials, quality, maintenance, and reporting. They give real-time visibility so we can act quickly and correctly. Examples: 1. Raw material availability and batch traceability. 2. Work orders and schedule priorities. 3. Real-time output and downtime logging. 4. Scrap codes and quality hold records. 5. Maintenance and breakdown reports. Controllers rely on accurate data to prevent errors and delays, and EISA examiners test this understanding. If I enter wrong info, production planning, costing, stock control, and traceability fail. That means risk to safety, quality, customers, and compliance. Typical daily system touch points include: 1. Startup verification and checklist logging. 2. Issuing and receiving materials to order. 3. Recording scrap quantities and reasons. And 4. Entering downtime, causes, and durations. 5. Confirming shift production counts accurately. 6. Completing quality hold or release steps. If I delay data entry, the system becomes wrong errors ripple through the business. Inaccurate inputs, poor planning, production, loss, discipline, issue. Workbook task. List 3 times per shift you must enter data. Then write the risk for each if data is wrong or late. For example, changeover time entry risk, incorrect OEE and overtime planning, scrap entry risk, traceability, failure, and investigation delays. Downtime logging risk, root cause loss and maintenance blind spots. Great controllers do not guess, they solve problems methodically. Problem root cause countermeasure check. I do not blame. I use evidence, observations, data, standards, and operator input. I treat each issue as a signal, not a nuisance. I protect the line and the product by thinking critically. 1. Define the problem clear, measurable, factual. 2. Investigate, observe, ask why, check records and SOPs. 3. Countermeasure, remove the cause, not just the symptom. 4. Check, verify performance improved, adjust if necessary. This method prevents repeat failures, exactly what ESA checks for. Scenario: output down 20%, scrap increased, 2 filler stops, new operator on shift. Workbook task: write the problem statement, identify causes, suggest 2 actions, and list what to monitor next shift. My decisions directly impact cost. Key cost drivers. 1. Scrap and rework. 2. Downtime and idle energy use. 3. Labor inefficiency and overtime. 4. Material handling delays. 5. Incorrect changeovers. 6. Late escalation to support teams. I reduce cost not by cutting corners, but by enforcing standards, improving flow, and preventing losses. On this slide, we are looking at the key cost drivers in production, the areas where my decisions as a process controller directly affect company money. Every stop, scrap item, rework cycle, or delay has a cost. So my responsibility is to protect resources while maintaining quality and safety. I constantly monitor waste and scrap because rejected product wastes raw materials, labor, and energy. I watch downtime and micro stops. Even short delays add up across a shift. I manage overtime by keeping production running smoothly so we don't fall behind. I avoid unnecessary rework by enforcing correct settings, first-off checks, and quality monitoring. And I control energy cost by avoiding idle running, using proper shutdowns and stable startups. In simple terms, a strong production controller doesn't just run the line. I protect money, time, and materials. Every action I take on the floor either saves the business cost or creates cost. So I work proactively, communicate early, and solve problems quickly to keep production efficient and financially healthy. Workbook task. List 5 wastes you've seen: movement, waiting, rework, unnecessary processing, inventory, etc. Circle 1. You can fix right your immediate improvement action. Let's begin with this activity. Shift reporting is proof of control and ISA measures it. My report must 1. Show plan versus actual with reasons. 2. List downtime by duration and cause. 3. Record scrap with code and quantity. 4. Note safety and quality issues. 5. Document actions taken and escalations. If it isn't recorded, it did not happen. You should include the following: output versus target, scrap, rework, and root causes, downtime log, quality concerns and checks, material readiness issues, safety observations, actions requests for support teams. My report feeds planning, maintenance, quality, and cost control. Complete workbook activities, POLC examples, system touch points list, mini case problem solving, draft shift report entry. We will discuss once completed. Quick recap checkpoints. 1. POLC model and your role. 2. MIS ERP touchpoints and risks. 3. Problem solving loop. 4. Key cost drivers. In the next session, we will cover quality control, assurance management. Thank you. See you at the next session. Great work. You are building the discipline expected from qualified process controllers.